Hello, my friends of Atari Labs. Welcome to this tutorial. This tutorial will be about field missing precipitation data with artificial intelligence by the use of Python Keras. In order to start this tutorial, we will work in Windows, but as well we need to have the Keras library installed. We use Anaconda for running Python. So if you want to install Anaconda in Windows, you have to go to Anaconda prompt. You have to look where your Anaconda folder is installed. In my case, it's D software. And this is the folder of your Anaconda installation. Look, you have to look for your own. Then you scripts and says I will use Python 3, no Python pip install Keras. Okay, so this is the code, this is the line to install Keras. In the case that it will require another library like TensorFlow, I guess you have to do this and then you install the TensorFlow. I mean the requirements. You have to look for the measures that will come from the from as well from the script and from this from the prompt. Okay, look, cool. So we have Keras installed already. So we are going to start. So we have what we have here. When you run Jupyter Notebook, actually you start here and you go to Documents. Yeah, and here is where you will find, here is where you place this deep learning folder that we will provide you. Okay, and this deep learning folder, you will have this station 1, station 2, station 3 CSV file. Yep, and as well as the Python script that we are going to do. So, okay, so you start a new notebook on Python 3, and this will be Keras, Python Keras tutorial. Python Keras tutorial. Okay, great. That's great. Yeah, first of all, we are going to import the data from the stations as a CSV. Okay, if you see, there are some missing data on station 2. Okay, and this is what we are going to look for. Okay, we plot what we have, and we have that we have station 1, station 2, station 3, and then there is a missing data here that we are going to fill. Okay, cool, great. So what else? I wanted to use something else, and this is a linear regression. I wanted to add the week of the year in order that provides something more for the neural network to run. Created this code that actually what it does is it inserts a week column on the data frame. So I run it. Okay, so I have here a week column. Okay, great. What else? We will plot a correlation. We will plot a correlation. It's a correlation matrix, but it's a graphic of the correlation matrix. So this is a graphic and says that station 2 is more related to station 3 than station 1, and that with the week it has a low correlation. Okay, linear correlation, but in any case, it's very interesting to see how it's correlated. Okay, then what we have here is we create our train. Our train data set will be the same as our test data set, and it will go from the 20th of January to the 27th of March. Okay, so, and this is our train, and this is our X and Y. So this is the input and this is the output for the train, and it's the same as okay, we run. Then we do some scalar. That why? Because we need somehow that all the data that goes into the neural network actually are on the same range. So actually, I mean, you don't need that one parameter go from 0 to 1, the other parameter goes from 0 to 10, and the other ones go, the period of the values, the range of the values are from 0 to 100. So for that, you scale your data with this by using some algorithm from scikit-learn. Okay, so if you want to see how your data is scaled, you can do this. Okay, this is your data, but already scaled. Then what we do is we are going to create our model, our neural network. Okay, we create our neural network. Okay, and then this is the output of our neural network. Okay, it's okay. I mean, this is how the neural network will run, but actually we have to compile, and then we have to fit. Okay, in order to run. Okay, we are going to use the model sequential and the dense layer. Yeah, and the activation for this is linear because linear are the only ones that are not bounded to 0, from zero to 1, because actually your precipitation actually goes beyond 0. Okay, so this is the dense, nothing else. And we have 12 layers. The first layer will have 12 neurons, the second will have 8, and the last one will have 1, that is the output layer. Okay, cool. With this we run, and then we see which are our predictions, because this is our predictions for the test. Here we know how well or how well is doing the predictions over the data, because actually what we are going to fill is station 2. Please remember that station 2 is the precipitation series that needs to be filled with data from station 1 and station 3 and the week number. Okay, so here we run this and say for station 2, I run it again. Okay, we see that there is a feeling, yeah, and there is a match in between the predicted and the observed. Yeah, could be better, but it is not, because actually we have few data. We only have two stations to represent the. We have two stations to represent the data of the third station. Yeah, and only we have 2 months, so it's not so rigid, but it's doing great. I mean, it represents great the most of the peaks, yeah, and most of the lows. Okay, great. So then we predict the missing data between the then we predict the missing data. So here is the data set for the missing. Okay, then we as well scale the data set from the missing. Yeah, and here is a we get the data set. I mean, we got the predictions. I mean, for this data set, that is where we don't have data. Okay, and then we add this to the data to the pandas data frame as a new column that will be called station 2 complete. Okay, it gives a warning, but don't worry about it, because it's a warning of overwriting. And then if we plot this, you will have the station 1, station 2, but the unfilled and the completed data set is this one, and this is station 3. Look, that this is, I mean, from the correlation, you saw that it's more related to station 3 than station 1, but somehow values, no, I think it's okay, it's doing great. Um, the, the fit, yep, I mean, on the shape is closer to this than to that. Okay, cool, so that's it. This is the neural network. Okay, you will have the input files and the Jupyter Notebook on the description of this video. What we are Hatari Labs. Hatari Labs is a blog dedicated to the promotion of open source software in water resources, but mostly we do numerical modeling, GIS, and programming. Yeah, we have a blog with a lot of tutorials. Yeah, and we have as well. Well, we have lots of tutorials. We have a Facebook page, a Twitter account. We have as well this YouTube video. So if you like what we post in YouTube, please do like to this video, and as well subscribe to our channel. Yep. And as well, we have one newsletter that you can sign up for new tutorials and so on. Okay, great. My name is Saul Montoya. Please have a great day and see you in another tutorial. Nothing else. Bye-bye. Bye.